finding zeros. What are zeros? Before we go ahead and take a look at this first example, let's kind of just dive into what zeros of a function actually are. And to do that, we're actually going to use our first example here, such that we have the function of x, such that is equal to x squared minus 6x plus 8. And to talk about zeros, what we're going to do is we're actually going to take a look at the graph. So to graph this, I would go into my y equals, I would type the equation that I want to graph, and then I'm going to press the graph feature. And so, as expected, we see that we get a parabola, which makes sense because we saw that it was a quadratic. We also see that it's opening up since the a value is positive. And another connection we can make is the fact that since the constant value is plus 8, we can see that our y-intercept looks to be up here around 8. But our question is, what are zeros of a function? And so zeros are the values that make the function equal to 0. So when we're looking at this, what we're actually saying is, when is this function equal to 0? Or in other words, when is the f of x, or the output variable y, equal to 0? So in essence, what we're looking for are the x-intercepts. So when the directions say find the zeros, it's basically asking us to find the x-intercepts, which if we make another connection, that's basically just asking us, to solve the equation upon setting it equal to 0. So to do that, what we're going to do is we're going to actually do the zero product theorem. So we understand that this is the function we're trying to find the zeros of. So if I go to factor this as x minus 4, x minus 2, now I can apply the zero product theorem because, again, I'm trying to figure out when is this expression equal to 0. That's what it means to find the zeros. So I'd say x minus 4 equals 0, x minus 2, which upon solving this, I get x equals 4, x equals 2. My zeros in this case are 4 and 2, which again makes sense because I see that my x-intercepts on the graph are also 4 and 2. So they have that connection. So at this time, what I'd like you to do is actually go ahead and pause the recording, and I'd like you to try to find the zeros of the function of the second example. All right, so now at this point, hopefully you already had a chance to try the second example. I'm going to go ahead and work out the second example here. And again, since we're finding the zeros, all I'm going to do is start off by factoring. And then since I'm finding the zeros, again, I understand that I can apply the zero product theorem. So this gives me x minus 5 equals 0, x plus 2 equals 0. And solving this, I see I have zeros at 5 and negative 2. If I wanted to check my work, I can actually go back into my graphing calculator. And now up here, I'm going to type my new equation, x squared minus 3x minus 10. Once I graph it, I see that I have my x-intercepts at negative 2 and 5, just like I calculated. So when the directions say find the zeros, they're basically just asking you to find the x-intercepts or basically to solve the equation upon setting it equal to 0.